Hi, I'm Dustin Harris, and we are the Wind Blazers. Class, we are given an opportunity to change the world as we know it by creating prototypes to create renewable energy.
The group chose wind energy because it has many problems that can be fixed.
Although wind energy is renewable and effective, it's very expensive.
Our project, we chose to enter a wind turbine in the Kid Wind project. This is our logo for our group, the Wind Blazers, and the only reason why this one has 4 propellers is because we wanted our name on each one.
Our research greatly helped us in our project. We found out that the number of blades on a wind turbine greatly affects the amount of energy it can produce. For example, a wind turbine with 3 propellers is much more efficient than a turbine with 1 or 2 propellers. We found that after 3 propellers, the efficiency stays the same, but the cost goes up. For our project, we brainstormed 3 separate ideas. Our first idea was to use 1 paper blade, a Kidwind basin motor, and fan for wind energy. The pros of this idea are, a fan is more reliable than the weather, using Kidwind material means that it will actually work, and for actual production it is the cheapest option. The cons of this idea are that paper can be very flimsy and 1 blade is very inefficient. For our second idea, we decided to use 2 cardboard blades, a Kidwind basin motor, and wind for energy. The pros of this idea are, cardboard is semi-sturdy, a Kidwind basin motor will function well. The cons of this idea are, wind can be unreliable and this project would be semi-expensive. Our final idea was to use 3 wooden blades, a Kidwind basin motor, and fan for energy. The pros of this idea are, the 3 blades are very efficient, a fan is reliable, and a Kidwind basin motor will function well. The cons, this project would be expensive in real-life construction. In the end, we chose to build option number 3. Although the actual real-life construction is expensive, the prototype is not. Therefore, all of the pros outweigh the cons. In order to perfect our prototype, we had to experiment on it. Our first experiment was to measure the turbine swept area calculation. In order to do that, we had to make 3 different types of blades. Our first blade was made out of construction paper, our second blade out of cardboard, and our third blade out of wood. In order to measure the turbine swept area calculation, you first have to find the radius of each of the blades squared times pi. Our second experiment was to determine that if the length, size, and type of material the propellers were made from could increase or decrease the voltage the turbine could produce. The results from our experiment were very helpful. We found out that the wooden blades could produce the most voltage and that it had a very high turbine swept area.
6 learning targets. The first one is to identify kinetic and potential energy within a system.
In our project, we use a fan for wind energy. When the fan and propellers aren't moving, they have potential energy. When the fan is turned on, it pushes on the propellers, causing both the fan and turbine to have kinetic energy.
Target number 2. Explain how one energy can be converted into another.
Wind comes from atmospheric changes, all of which are triggered by the sun. So in a way, wind energy is another form of solar power. Wind turbines capture the wind to produce energy. When wind turbines spin in the moving air, they produce power which is transferred to an electric generator.
3. We needed to develop a model that demonstrates energy conversion.
In our prototype, when the wind pushes on the blades, they spin on gears. The current is then transferred to a meter that can measure the voltage the turbine can produce.
4. We needed to explain the law of conservation of energy.
The law of conservation of energy states that the total amount of energy can't change. So the sum of energy put in the wind turbine plus the remaining energy in the air after it passes through the turbine must equal the energy in the wind before it entered the turbine.
Number 5. We needed to build a prototype that maximizes energy efficiency.
In order to reach maximum efficiency, we first had to do research. We found out that the most efficient wind turbines consist of 3 propellers and pointed blades. When we made our 3 wooden blades, we found that they were more efficient with square instead of pointed tops because they had the potential to catch more wind.
At least we needed to utilize technology to improve energy conversion.
In our project, we used the most up-to-date Kidwind turbine kit available. For example, in our experiments, we were able to use multimeters and voltage measurers.
During the course of making our first prototype, it just vanished, disappeared. So this is our second one that we have made. Oh, we encountered many problems, but we overcame those problems to make this beautiful prototype that we entered in the Kid Win Challenge.